Okay, so today we are skipping all the way to chapter 21 to talk about area. And we're going to jump right in with area of parallelograms. We had a little bit of a preview by using our graph paper and looking at how it relates to rectangles. But our learning goal today is to be able to use a formula to find the area of parallelograms. So let's review just a bit. We already talked about how a parallelogram is a quadrilateral. What does quadrilateral mean? Sadvika?
It has 4 sides.
Okay, a figure with 4 sides in which both pairs of opposite sides are parallel. So let's draw some examples. Go ahead and write this T-chart in your notebook. Parallelograms and not parallelograms. So for example, we already saw that a shape like this is a parallelogram. Does it have 4 sides? Okay, are the 2 opposite sides, are they parallel? Okay, is this a parallelogram? Does it have 4 sides? Are the 2 opposite sides parallel? Okay, that's the checklist you need to ask yourself. Does it have 4 sides? And are the sides parallel? Let's talk about this shape. If I drew it better, let's think about a diamond shape. Let me try drawing it better. Hang on. Is this one a parallelogram?
No.
Why not? Ria? It does not have 4 sides. Is this a parallelogram?
No.
Does not have 4 sides. Is this one a parallelogram?
No. Yes. Yes. No.
Carmel, why do you say yes?
Never mind. Actually, because a parallelogram has 2 pairs of sides that are parallel, but that only has 1 side.
So Carmel's saying, oh, it does have 4 sides, and these 2 lines are parallel. But are these 2 lines parallel?
No.
So therefore, this is not a parallelogram. Okay, so let's define some words really quick. Here we have a parallelogram that is drawn, mediocrely. That's fine. And the base of a parallelogram, and you want to be writing these vocab words down in your notebook, the base is any side of a parallelogram. So typically I like to call the base just the bottom. The base is from here to here. Okay. Now the height is the length of a perpendicular segment from a vertex to the base. So we know the vertex is another mathematical word for a
Corner.
Good. So there's the corner, there's the vertex. If I'm going to draw a line down perpendicular from the vertex, that means it needs to be how many degrees?
90.
So I'm going to draw a straight line 90 degrees down from the vertex until it meets the base. And that is called the height. Okay? And because we did our little graph paper exercise where we knew that we could cut off this triangle and move it over here to form this new shape, we know that the area of a parallelogram is the base times the height. By looking at this, what can we say is the formula for the area of a parallelogram? What is our magic formula that I will write in green? The area, A, equals... Michaela, give it a try.
I don't understand the question.
Okay, what's the formula for an area of a parallelogram? We saw that if we move this triangle here, over here, we make a new shape, which is a rectangle. Now, how would we find the area of this rectangle?
You do height times base.
Good. And is the area of that rectangle the same as the area of the parallelogram we had before? Very good. So what is the formula for the area of a parallelogram? Big A stands for area. How would we find the area?
You do height times
Good. So base times height. So the magic formula for the area of a parallelogram is the...
base times height.
Let's say it together. The area of a parallelogram can be found by multiplying the...
Base times height.
Good. So now we know our formula is area equals base times height. Right, Abiram?
Yeah.
You should be writing this down, shouldn't you? So here's a parallelogram. What is the base? How long is the base? How long is the base, Christian?
The base is 7 inches.
And how tall is the height, Andre?
The height
Is the height 5 inches?
Oh, 5.5.
Oh, 5 and 5/10 inches, 5.5 inches. Good. So how can we use our formula to find the area of this parallelogram? What do we need to do? Riley, what do we need to do? Good. We know that the area is the same as the base times the height, which is 7 times 5.5. Can we do the math? Let's do it, please. So let's do 5.5 times 7. 7 times 5? 7 times 5 again? Good. So 385. Is that my answer? Oh, how do I know where to put the decimal? Kevin?
Move it down. Exactly.
Do I just look at where it is and move it down? Is that how it works for multiplication?
Oh, no. Okay, no. So, since the 5.5 is the only one that has a decimal,
Mm-hmm.
you just keep it, like, where the decimal is.
So I know that I only need one number after the decimal.
But
Good.
if the one also had it, would be like 2.
Very good. So what is my answer? 38.5. I heard it. Square inches. Muy bien. Very good. One more. Kimberly has designed a set for, for play. But really it should say for a play. Miss O typed it wrong. The base will be 30 feet and the height will be 15 feet. The technical director needs to know the area of this set so she can mix enough paint. What is the area of the set? Well, let's draw the parallelogram first. Apparently they're doing a set that is a parallelogram. Okay, what's the base, Chris?
The outside.
Okay, and how long does the problem say the base is? The base will be,
30 feet.
okay, 30 feet. And what is the height? What is a height? Aditya?
15.
It is 15, but how do I draw it? Where should I write? How can I draw it on my picture? On my diagram?
Make a line.
From where?
The vertex.
Oh, from the vertex, okay. And it needs to go down perpendicular. So is that good?
Yeah.
More or less, very good. And what is the height? 15 feet. And so how do I find the area so that the set director can be sure that she has enough paint to paint the whole entire thing, Daniel?
You multiply 15 by 30.
15 times 30. Let's do some multiplication, shall we? 0 times 5? Thank you. 0 times 1? Put a 0 here because I'm now going to multiply tens. 3 times 5?
15.
Carry the 1. 3 times 1?
3.
Plus 1? Add it all up. What do I get? 450. Do I have any decimals to worry about? No. 450 square feet is my answer. Thank you, Fayron.